All right, so my name is Esteban Virelas-Rocha. My project is the power pocket supply in engineering 10. So power pocket supply problems. Due to COVID-19, my biggest problem was shipping time and rates. Shipping times were a week or 2 weeks out at the time, causing me to fall a bit behind schedule. Another problem I had was having to learn how to solder on my own. It took a lot of trial and error before I was finally able to fix my project the way that I wanted it to be. In addition, after review, I decided to add a USB Type A female port to my project to allow charging of the phone, which was not completed due to shipping time once again. And then a few of the solutions. I saw solutions as two different things: solutions for my problems during my project and solutions that my project could bring to the people because of it. One of my biggest solutions for my project as far as shipping goes was Amazon Prime. It take longer than usual, but it was just the right amount of time to complete my project. Also, YouTube was a tremendous help when it came to learning how to solder, how to stay patient and keep after it, multiple trial and errors, but I finally got it down. As far as solutions for the people, I would be able to produce a cheaper portable pocket supply at our leading competition like Mophie or Pelican. It would come in colors that the customer can customize and also for the specific type of charger that they need. No more getting caught with your phone being dead. If you stay ready, you never have to get ready. And then, so this is the part list. If you notice, a 9-volt battery, there was no shipping date because it was purchased at Target. And then you have the resistors that I bought, the PCB board, the soldering iron, and the voltage regulator. I wasn't able to put on a USB Type A female port only because arrival time for it was going to be beyond the time of what we had in class. But in total, with all this, it came out to $85.99. There it is. All right. Power pocket supply theory. So the maximum output voltage is 7.75 volts from the calculations below. The main piece in this project that I really have to take into account is the LM317 voltage regulator. A data sheet from Texas Instrument helps me understand the performance while showing us the limits. The data sheet shows that the voltage output limit is between 1.25 volts and 37 volts, and the current limit is between 0.01 and 1.25. We will compare the output voltage for each switch position with a voltmeter. The results form LT spice and the theoretical calculations. Comparing them, we will get the difference between the simulated versus calculated and the actual versus calculated results. With that being said, I also ordered a USB Type A female adapter to hope to solder onto my project. Due to COVID, however, I will not have the time to solder it on once it gets in because it arrives a week after the class is over. Although I think I will still try and solder it on my own just to see if all my hard work pays off. Once it is all said and done, my theory is that I should have a power pocket supply package charge my phone. And so this is the Gantt chart. If you notice, on July 25th, I didn't do any of that work, which kind of caused me to fall a little bit behind. And then at the beginning of the project, I also was slacking off a lot. My biggest struggle was trying to stay motivated through it all. If you notice, I did not get to solder the USB Type A email port due to the TIF that it was not going to arrive until next week. I will include a picture as how it looks later in my slides. And then this is the PERT chart. So my PERT chart was made for me to easily keep track or exactly what I was doing and the steps that I was going to follow. I feel like it helped me a lot in the sense that I was never asking what to do next. I automatically just looked at it and knew what was next. If I had to make some changes, I feel like I would have added a bit more detail, but that will be for future references. And then, so basically I added again the solder USB type. By this point, we already know that like I wasn't able to include it in the project. But besides that, I was able to get everything else put together. And then as far as my survey goes, according to my surveys, 70% of the people wait for their phone to get to 20% battery life, while the other 30% either will charge it like at 30% or like 40% or 50%. 90% of people don't carry portable charging packs, while the other 10% said they did. 48% of the people will wait until their phone dies to finally charge their phone, which is honestly pretty bad for your phone. 52% said that they wait until either it's like at 10% or 15%. 50% of the people think it is too expensive to try and buy a functional battery pack for their phone. And then this is of the testing results that I got. For the first like 1 through 4 switches, I was able to get the volts to go from 1 volt all the way up. From 5 to 8, however, it kind of staggered on me a little bit. For some reason, after I think it's the 4th or 5th switch, there's a lot more percent error for some reason. And then this would be the explanation of my graph. Basically, the output voltages of the theoretical values, simulated values, and actual values of the schematic, as well as the percent error between theoretical and simulated, and theoretical and measured. Have you noticed from 5 to 8, the errors simulated is actually really increased from the error actual. So the error actual, for some reason, after switches 4, 5, 6, and 7, to increase a lot more, and I think it has to do a lot with the way I calculated it. And then as far as human factor goes, when considering human factor, I wanted to make sure that the simplistic of it helped our customers. I did not want them to feel like they needed to press too many buttons to get it started. All that is needed is a USB cable and to press the on button. It is also designed to fit the average pocket of denim jeans. It does not weigh too much, so it should not weigh down the customers as well. For future editions, would be that the customer would be able to customize their own by choosing the color that they would want. And then on the left here, if you could see, it's the hand-drawn schematics for a voltage regulator. In addition, on the right is the finished product without the USB. And then if you look at the blue box right there, you could see the switches from 1 all the way up to 8. And then in the center was going to be a USB Type A female adapter where I was going to solder it on. Results. After further testing, I realized that the product works exactly how I want it to work. When flipping the switch after the fifth time, the percent error increases when more voltage is outputted. After further calculations, it came to my attention that the circuit does not allow to produce more than 8 voltages. For future projects, I would want to focus more on building a stronger and compound circuit that would be able to handle the voltages I throw at it. Conclusion. His project explored how to use the LM1317 chip and understanding how to use it as a variable voltage supply. Testing my circuit on LT Spice was a significant step before I could test our power supply. After analyzing the results from our LT Spice simulation, I was able to conclude that our circuit design is perfect and will work for the final build of the project. Our calculated results for the output voltage show that it is similar to the simulated results up until the net resistance is 1350. The percent difference after 1350 is due to the voltage in limit, thus forcing voltage out to stay between the value. The measure results displayed the pattern that I predicted with my simulation, with voltages past 1,350 ohms, showing an increasing percent difference. I could lower the percent difference by connecting the circuit to a larger power supply, which in turn would increase the value for voltage in and increase the limit for the voltage out. Implementing these changes to my project will reduce the percentage difference and therefore will make my overall results closer to theoretical results. Thank you for listening.